Now let's see power set. If capital A is a finite set, so one more thing, power set is defined. Generally you can do it for infinite sets as well, but then in set theory here we'll be doing it only for the finite sets. So if a set is finite, then only we are going to define the power set. So see this, if capital A is a finite set, then set of all subsets of capital A is called power set of A. It is denoted by P of A. So I'll just explain you what it means. Let us say we have a set capital A with two elements A, B. Okay. Now we have to find out all the subsets of this set. So what are all the subsets of this set? First we have to go with the subsets of cardinality 0. And one more thing, there is a term called as cardinality of a set. The cardinality of a set is nothing but number of elements that are present in the set is called cardinality of the set. For example, in this set we have two elements, therefore cardinality of set A is 2. Okay. Now we should find out all the subsets of this set A. Now what is the minimum number of elements that can be present in any subset? 0. What is the maximum number of elements that can be present in any subset? 2. Therefore we have to find out all the sets which are possible of size 0, all the subsets of this, and then of size 1 and then of size 2. Let's find out all the subsets which are possible which are of size 0. So only one set is possible which is of size 0, which is nothing but 5, the empty set. And what are all the subsets which are of size 1? Only two subsets are possible which are of size 1. What are they? One is A and the other is B. And what are the subsets which are of size 2? 1, A comma B, right? Therefore this is the set, this is the all subsets which are subsets of A. Now what is power set of A is? Power set of A is nothing but set of all such subsets is called as power set of A. Got it? Therefore how many we got? 1, 2, 3, 4. So the cardinality of power set of A is equal to 4. Now let's take one more example. If A equal to A, B, C, right? Then how many subsets are possible? There will be subsets which will be possible of size 0, and there will be subsets which will be possible of size 1, there will be subsets which will be possible of size 2 and size 3. We cannot form a subset with more than 3 elements. 3 is the maximum, right? Then what about power set of A? Set of all subsets. One is set containing 0 elements, which is 5, and then set containing 1 element. So what are the subsets containing 1 element? A, B, C. And then sets containing 2 elements. What are the sets containing 2 elements? A comma B, B comma C, right? And C comma A. And the other is set containing 3 elements. What are the set containing 3 elements? A, B, C. Okay, now you count them. 1, 2, 3, 4, 5, 6, 7, 8. Therefore, if A contains 2 elements, then power set of A contains 2 square elements, right? And in this example, second example, if A contains 3 elements, then power set of A contains 2 power 3, which is 8 elements, right? In general, if a set A contains n elements, then power set of A contains 2 power n elements. Are you getting this? One other way of saying it is, if a set contains n elements, then the number of subsets for that set are nothing but 2 power n. If you want to see why it is so, just observe this. Now if you have, let's take this example only. Now if you have 3 elements A, B, C in a set, let's say A, right? Then each element will give rise to will actually give rise to two types of sets. So either this element can be present in a subset or this element may not be present in a subset, right? Therefore each element will give rise to two chances, and either this element can be present in a set or this element may not be present in a set, and either this one may be present in a set or this element may not be present in a set. That is how we get 2 into 2 into 2, that equal to 2 power 3. Got it? Okay, so what I mean by this one is, if you are not able to understand this, maybe you can think of it this way. Considering A can be present in a subset or A can be not present in a subset. Now considering the element B at the next phase, B can be present in a subset, B can be not present in a subset, and here B can be present in a subset, B can be not present in a subset. Considering the element C, C can be present in a subset, C can be not present in a subset, C can be present in a subset, not present, right? Similarly, C can be present, not present, C can be present, not present. Now if you observe this, see this, A is present, B is present, C is present, therefore this subset is A, B, C, right? And A is present, B is present, C is not present, which means this subset is AB. Likewise, if you write, you are going to get 8, isn't it? That is why 2 ways for A and then 2 ways for B and then 2 ways for C. 2 into 2 into 2, that is why 2 power 3. In general, if you have n elements, then each element can be present in a subset or it cannot be present in a subset. Then we are going to get 2 into 2 into 2 into so on n times. Then we are going to get 2 power n. Okay, that is all about the power set. So it is very important that you understand this, because later we are going to use the same theory to build the relations also. So what is the point here? If A contains n elements, then the number of subsets of A will be 2 power n. Okay, and one more interesting thing is, in the number of subsets we are even counting the trivial subsets, which means phi is also included and AB is also included. So phi and the set A itself are also subsets, so counting them we are going to get 2 power n. Okay, remember this point, very important.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.